Hello and welcome back. This is the famous slope walk problem of calculus done virtually. So I think I'll probably be the first math teacher at LCAP to be doing this slope walk video virtually, and we're gonna have fun with it. It's that's all I'm gonna say is we're gonna have fun with it, laugh about it, and that's part of life. You gotta laugh about things. So this is the problem, and I'm outlining here, and I'm gonna do two examples here to show you. Now, when you do this one, you cannot choose these. I'm taking these away from you. And if you want to work on with someone else, if you are working with someone else, that's great. Just make sure both people are on the video so I can see that both of you worked on this together. All right. Now, for this problem, we're looking at a position graph. That's going to be distance versus time. And there's three things you want to accomplish in this problem. Sketch the transformed graph, walk the sketch, and you're going to record yourself, and I'm going to show you what that looks like. Not the recording, but I'll show you like what you're recording yourself doing, assuming you're doing it right. And describe in words either on paper or through audio what's happening here, why you walking the way you are. So let's look at example one. We have the function f of x equals x squared, quadratic function. Let's write the transformed graph. So when we go f of x minus 5 plus 5, which, by the way, hopefully you know that this transformation is making you go right 5 and up 5. So if we apply that to x squared, it's just going to be x minus 5 squared plus 5. Okay. And then let's make a graph of this. Okay. We're going to go by 5s here, because I know that quadratics get large pretty quickly. I don't have a graph to apply that. And this is time. This represents distance. And for the purpose of the video, we're going to use feet. And this will also go by 5s. Now, what does this graph look like? It's a parabola that gets shifted right 5 up 5. So right 5 up 5, that's the new vertex. And parabolas always kind of follow this shape here. Okay. Now, when I do this walk, let's understand what this graph is doing. So this is 0, this is like our starting point. And we're starting 5 feet away. So we're 5 feet away when we start. And once time happens, you're doing 10 seconds. So I'm going to like the 15 second time in seconds. We're moving away from the start. So we're moving away. And not only are we moving away, but we're going to be getting faster and faster, right? Because the velocity is the slope of this distance graph. And the rate of change at which we're moving away, like the rate we're moving away faster and faster away. So our velocity is increasing. We're getting faster and faster as time is ticking. Right? Now, I'm not going to do the slope walk yet because once I move my camera away, I want to do both of these at once. So I'm going to also do this example too, and then I'll show you how both these look. Okay. Now, example 2, f of x equals x. What's this one look like? Is if we transform it, that will be x minus 5 plus 5, which does simplify to 5, or just x, but I'm going to keep it as in that form here for the purpose of this problem, because I want you to start at the 5-second mark when you record your video. The time, and I'll also go by 5s on both for consistency here, and distance is in feet. In seconds. So at 5, 5, you start and it has a slope of 1, and linears just go like that. So when I do my slope walk for this linear equation, right, same as before, there's a 5 feet, I'm 5 feet away. I'm moving away from the start. And I actually have a consistent rate of change. I have a constant rate of change. Right? I'm actually going 1 foot per second the entire time away from the start, right? So it's a positive velocity. So the velocity is positive, but constant. Positive, but constant. hopefully you can read that and zoom in. Sorry, it's a little bit messy. All right, now I'm going to do the slope walk. This is the fun part of the problem, which I wish we were in class doing this, but I also don't want, we need to be safe during these times. So I'm going to unplug my camera. I think it's going to show my entire webcam. I'm going to move my computer away so you can see all of this. And then I'm going to try to outline both of these graphs and what they look like on the slope walk. So let's see how it goes. It might be bad, but I can't actually see my webcam either. So I'm just going to take my chance. Here we go. Oh, yes, I can see my webcam. Perfect. Okie doke. So let's say if I put it back here, my little workstation, angle it up. Okay. So we'll say that this is the start, and I'm 5 feet away. So if I'm doing the f of x equals x squared, the transformed, what's happening the first 10 seconds is I'm moving away, but then I get faster and faster and faster. And I guess that's x squared. And I hope your video looks better than that, but that was me demonstrating a positive velocity increasing as I moved on at time. And then the second one here, f of x equals x, I start 5 away, but I actually have a constant velocity. So I'm going 1 foot a second the entire time. My velocity is not changing. So there you have it. That is the slope walk. I hope you have fun with it. You do it. And again, you can't choose those two. You can't choose a quadratic, f of x equals x, and you can't choose linear, f of x equals x. And you only have to do one. But if you want to do more, I won't say no. And possible extra credit, I haven't decided yet because it's a good activity for you to understand too. All right, have fun with it. I'm looking forward to seeing your videos.